Now recording. So, how's everybody doing today?
Chilling.
Excellent. Chilling like villains.
How about you?
Oh, you know, I'm just doing my job that I'm being paid for, as usual. Yeah. So, you know, I get paid to do this. Act like a goofball in front of people. I sometimes joke with people that I shout at people for a living, which is kind of true. So, I like to think of it more like shouting with people, rather than at people. Anyway. So today, we are going to further explore the topic of taking inputs from a incoming request packet. We're also going to discuss how one goes about validating various data types, and we will be talking about cross-site scripting attacks. So, let's get started then. So, for those of you who have only just arrived, please open up VS Code and XAMPP on your computers so that you can follow along.
Is that it crashes anytime like I just screen share on this
You have to share your app.
It's so weird.
I am going to make there's a lot of chit chat going on.
We were complaining about Microsoft.
That's my job. Please make a new file, example.php. For me, it's going to be example2 because I teach a class immediately before this class in the class. So. Stealthy. That was awesome. So last time in class, I showed you how to use filters to remove special characters or transform special characters in incoming string data from the client. What do we never do with the client?
Never trust the client, never trust.
Very good. Never trust the client. So, in the last class, we were doing things primarily with get method parameters. So, for today's class, we will talk about post method parameters. So, quick review. What is the difference between get and post? Yes.
Does get gather data and post pushes it to a place?
Yes, so those are like what the verbs mean, right? So the idea with get is that you are requesting some data from the server, you are getting something. With post, you are posting something in the sense of sending a letter, right? That's like the origin of the term post, I believe, is in snail mail. You would send things by post. You would take your letter to the post office and send it by post. So, okay, but functionally, what's the difference between get and post?
Get is used for like filtering or paging, and post is used for like submitting forms and modifying data. You want to?
Okay, yes. So in general, get is used for sending particular types of things. Post is used for, that's a lot of classes. I just noticed how many glasses, 4 pairs of glasses there. People lose too many glasses in this room. Yes, so post and get, you send different types of data. Post you use primarily for form data, but here's the question I'm asking. Why? Why do we use post for form data? What is it about post that makes it different from get?
It's more secure.
Why? How is it more secure?
I don't understand.
Yeah. It's good that you remembered that it's more secure, but how? How is it that post is more secure than get? Anybody remember? What is the actual mechanism?
It hides data from the URL.
It hides, post hides data from the URL.
From like an input URL.
Hides how?
It displays it basically. Like if there's a script that's going on, it'll display it.
Like the special characters thing, right?
Yeah.
Yeah, so it'll put it as just text, like any script line.
Yes.
So it's just simply text.
Yes. So with get, yes, the get parameters occur in the URL of the request packet. Yes. So where do the post parameters end up? Somewhere they can't be seen. Starts with a P. P-A. P-A-Y. The payload, yes. So this is how packets work, roughly speaking, all right? So HTTP, read HTTPS packets can be roughly broken into two regions. One, you've got the header. Two, you've got the payload. Right? The header contains all of the important routing information for the packet. What is my destination? Where did I come from? What part of the world did I come from? Which browser sent me? Right? All of this information which is necessary for this little packet of information to pinball itself away around the network infrastructure to arrive at its eventual destination. Okay. The payload is, what is the payload? What do they do to the payload so that people can't read it?
Encode it.
Encode it. We also call that
Sanitize.
encryption. That's right. Nope, not sanitization, encryption. So the payload is encrypted. The header is not encrypted. Why is the header not encrypted?
Because it's normal HTML.
Well, no, the header isn't encoded in HTML. Yes.
Is the client, well, we're not giving it to the client, it's just, like, the client won't have access to it?
No, the client has access to the header and the payload because both the client and the server can encrypt and decrypt the payload, and the header is unencrypted. Because before the packet communication occurs, they perform a handshaking operation to agree upon a mutual encryption key. So both the client and the server have full access to the contents of the packet. My question is, if it's so great that the payload is encrypted, because that means that your data is at least somewhat private, why wouldn't you encrypt the whole thing? Make the whole thing, make it so that the whole thing couldn't be read. Yes?
We need something to be ready,
Why?
so that way we can decipher where it's going.
Precisely so. If you encrypt the header, that's all of the information about where it's going to, where it's coming from. That's the important routing information. If you encrypt the routing information, then all of the routers and servers and switches that compose the internet won't know where to send the packet. because it's just a bunch of blobs of encrypted binary information. It can't be read. So, the header must be unencrypted. The payload is encrypted under HTTPS. So, get parameters are stored in the header, most particularly in the URL. Post parameters are stored in the payload. So post parameters are encrypted. They are only viewable, in theory, at either end of the communication. Does this make sense? So, quick little quiz then. I'm going to give you a couple of different types of queries, a couple of different scenarios. You folks have to vote on whether you think you should do that by get or do it by post. Alright? So, first scenario. You are requesting a particular YouTube video to view. Who thinks get? Who thinks post? That is a situation where you would use get. In fact, YouTube itself uses get parameters for that purpose. It's actually kind of fun to play with the get parameters on YouTube. Here's something that you may not know that you could do. YouTube.com. There we go. Search, let's see. There we go. There we go. So, a thing you may not know that you could do on YouTube is if your video is at a particular timestamp, if you right-click, copy video URL at current time. If you open up a new tab, you can see, well, it's a little bit small, but if you take and my thing is obscuring it. If you take a look here, so that's an unfortunate number to have happened to stop on. So you can see that the time in seconds is specified as t is equal to, and then that number, right? Which means that you can actually modify that. If you press enter, then you just get stopped at the second that you requested, right? Or, within a second of it anyways. But you can also modify that and say, okay, give me second to 200. And there you go. There's second to 200. Oh man, he's looking old. Jeez. So, yeah, get parameters. $1.5 billion views.
I think he did another one. Another video.
Yeah? No? Well, whatever. So, different scenario. Let's say that you are purchasing a subscription to an online magazine. Do you use get or do you use post? How many people think get? How many people think post? How many people are ignoring me? Yeah. So yes, when the information is sensitive, you want to put it in the encrypted portion of the packet, which means putting it as a post parameter. Very good. So, for the purposes of in-class demonstrations, I am going to produce packets containing post parameters using HTML forms. This is kind of a little less JavaScripty, Even if you are in this class having not passed or having not attempted JavaScript, you should have at least done HTML. So we're going to use HTML forms. They're just a little bit easier to work with than AJAX requests, which can do the same thing. But anyway, so I'm going to make a little HTML form. Form. There we go. Action. I'm going to have this form target itself. Example, in my case, example2.php. Method will be that's the point I'm pausing so that someone can say the word.
Post.
Thank you. There will be there will be student interaction in this lesson, come hell or high water. We will have students participating. Let's give it a couple of inputs. So input type is equal to text. Let's make that number of, what's a comedy animal?
Elephants.
Hey?
Elephants.
Elephants? Yeah. Giraffes? Elephants is good.
You just don't want to
Yeah.
go grab. No,
Next, average mood of elephants. Input type is equal to text. My basic store of comedy animals includes bees, ducks, goats, and weasels. But I wanted some, someone from the audience. So, so far so good. Which, sorry? Line break? Oh yeah, that'll help. Oh, we also need a submit button. Line break. Line break. Input type is equal to, I hate the low keyboards. Submit. Value is equal to post those pachyderms. Good. So, when we submit information via this form, we will call this thing again, passing those parameters as post. Let's throw in some PHP to pick them up. For the time being, I'm going to do the thing that I told you never, ever, ever, ever do. Echo JSON encode my post superglobal. Why do you never, 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 never do it? And don't say because you'll lose marks, although that's also true.
You'll get hacked, son.
You get hacked, son, that's right. So, if this contains an embedded scripting attack, you will fall vulnerable to it. So, good. My goodness. Yeah. What a way to run a railroad. So, here we go. Loading our web page up, we get the following. Just gonna put that right there. Works. There we go. So, if we enter some data in and then send a post request, let's see what happens. Number of elephants is 99. Average mood of elephants is
So-
Grumpy is pretty good. 99 grumpy elephants. It looks like things didn't work. There's a problem here. Can anybody spot the bug? Anybody care to guess? Bug spotting is going to be like 70% of your work lives, so
Did not post properly?
it did not post properly. Yes. So, well, I mean, it did send a post request.
I mean, I assume it was supposed to fill the array.
Yes, it was supposed to fill the array, but it didn't. That's what the bug is. Do you know what there is causing that bug? Or can you take a guess?
Because the PHP is outside the form?
Nope.
That's ridiculous.
The PHP is outside the form, so what it prints occurs lower than the form. That's correct in the way it should be, actually. Yes?
Does it have like no destination?
No, it has a destination because it is arriving at the server, right? The fact that this even ran at all, right, means that the server was activated. So the packet was routed correctly. But we're not getting the data.
Because there's nowhere for it to go. It doesn't look like there's a spot for it to go on the client.
It doesn't look like there's a spot for it to go. What do you mean by spot for it to go?
Like the data is being sent to the server, but where is it like going?
In the JSON code.
Well, when the data is sent to the server, it gets placed inside of the post superglobal, right? So perhaps we should pick apart the packet to see what's going on.
Ooh.
So if I reload, go, or let me send 1, 2, 3, go. Please don't destroy the equipment, thank you. So if we take a look inside of the, we've got preview, header, response, initiator, timing. We don't even have a payload tab, right? So somehow, this thing is not actually sending any data. Why? There is something wrong with it. Anybody remember their HTML? What?
It has to be something really obvious when you forget.
Yes, it is something really obvious, that's true.
Is it because we didn't even declare any HTML?
We didn't declare any HTML?
Like HTML and closing brackets.
Docs say.
Oh, you mean like the doc type thing? No, that's not the case. Yes,
Is it the input type submit?
the input type submit. No, that makes the submit button, but you're getting warmer.
Is it the fact that we don't have an ID?
Not ID.
Div?
What's the other one?
Class?
Not class.
Element?
Not element.
Div? Person?
I think I heard it over here. No?
Div?
That's it!
Something.
Name. It's missing name. So, on HTML forms, the name here becomes the name of the parameter that is sent. If there is no name to the input element, it doesn't just make one up. So, if we include name is equal to n, name is equal to m and n for number and mood. There we go. Save. Try again. 88 elephants. Average mood is unfriendly. Now we can see. Did that save? Save. There we go. Number of elements, 88, or number of elephants, not elements. Mood is
Tired.
reflective. So we have 88 reflective elephants. Our post parameters are picking things up correctly. Yay! So, any questions about that so far? Yes.
Can you explain the whole name thing?
Can I explain the what, sorry?
Like the whole name thing, explain the whole thing.
Sure. So, the question kind of comes down to how is the packet being formed, right? When we create a form like this, we are saying, like it's automatically saying each one of these input elements will become a parameter that gets sent in the packet, right? In this case, via post. If the input element doesn't have a name, we can't send a key value pair because we're missing the key. So it just skips it. Does that make sense?
So it has values.
Yeah, well, yeah, like the values still exist on the client side, but to compose the packet, it has to be key value pairs. Without the key, there's no pair, nothing gets sent. Does that make sense? Any other questions? Yes.
So for the JSON underscore encode, what do we like use it for?
It's an excellent question. All right. That's such an excellent question that I'm going to have to do it on the board. Don't worry about these two. We'll get to meet them later. So, the whole question is the data you're dealing with a native data structure or is it string encoded? Right? So, on the client, in JS, you might have, I'll talk about the JavaScript versus sending via AJAX example because it explains everything else too. So let's say in JavaScript you have a data structure, right? Let's call it rats, right? An array of rats or a dictionary or some sort of like a JavaScript object describing a collection of rats, something like that, right? This has data type. It is a native data structure, right? Do you know what I mean when I say native data structure? All that means is it is an array or an object in the programming language itself, right? So when you work with an array in Java, that array is a native data structure in Java. When you work with an object in JavaScript, that object itself is a native data structure in JavaScript. It's native to its programming environment, right? We don't have to worry about the memory management stuff. We just know that that array belongs to the program, right? Does that make sense? So far, so good?
Yeah.
So, the problem comes if we are trying to send the information in a native data structure to our good friend the server. We have the problem that the network infrastructure will only take strings, right? So, I want everybody to envision that there is, there we go, that there is a big, unhappy troll yes, who has a big club that says not string alright? And he's watching the internet, and anything that's not a string, he whacks it, and it dies. Alright? So, if we were to send native data structures into the internet, whack! Doesn't work. So, what you do is you JSON encode something. JSON is a string representation. JSON means string, right? So, in JavaScript, does anybody know what method we use to create a string from a native data structure in JavaScript? The name is kind of fun.
Stringify?
That's it. JSON dot stringify. So, through the process of stringification, we get rats string, which is now a string, which means that this string can now pass through the internet. It can go past the troll without getting whacked. So, we can now send the rats string to the server using a request packet. The server receives the string, rats string. This is, of course, a string. If you've ever tried to work with an array or something as a string, it's terrible. Don't do it, right? Arrays are lovely. With arrays, the index of the thing you're looking for is not dependent on the length of the thing you're looking for, right? If you're trying to work with an array that's like 0, 10, 4, and you wanted to access like that number, you have to like calculate how many characters come before it, then take as many before the comma. It's terrible! You don't want to do that! You don't want to do that. You don't want to have to parse your own data structures. Never, never parse your own data structures unless you are doing it for fun. So, we have in PHP a lovely little function called JSON decode. JSON decode, and that is also a function. JSON decode takes the string, turns it back into a native data structure. Once it's back in a native, back as a native data structure, you can perform whatever operations you want on it to mutate the data, right? Mutate just means change. Do you have a question?
So it's basically like, almost like a Trojan horse after it gets, and then it gets turned back anyway, right?
I mean, if you want to consider the fact that like you can only send strings to begin with, a Trojan horse, you're not really Trojan horsing someone if you're just abiding by you can only send strings. But yes, in this scenario, that's yes. It works as a concept. Yes.
So is JSON.stringify like the equivalent of JSON_encode?
Yes. In JavaScript, yes. They perform the same operations. So we have rats in our native operating system. We now perform the mutation of the data to get mutated rats, right? Then, let's say we wanted to send mutated rats back to the client, all right? In that case, we now use JSON encode to turn mutated rats into mutated rats string, which is of course now a string. Again, you would send that back out to the client, normally in the form of an echo. So you would echo mutated rat string. That sends the response packet, which the client is waiting for. Again, because it's a string, we get past the troll that's sitting on the internet. We receive mutated rats string. It's a string. So if we want to work with it as a native data structure, we have to use a function in JavaScript called JSON.parse. Parsing is the process of taking a string and reading the data out of it into some other form. Parsing is the thing you do with a programming language as the first, parsing is the first thing you do with a program when you are feeding it into a compiler, for example. JSON.parse, we now have mutated rats in our client. The whole time I was doing that, I was hoping some kind of joke or pun would come to me for the end to like close off this, but
It should
It
have been
didn't.
parsified.
what?
It should have been parsified. Because
It
stringify
should have
sounds-
said, yeah, it should have been parsified.
Stringify sounds like it's spelled in Harry Potter.
Yes. Although the problem is like, I think it's kind of technically grammatically correct English because like string is a noun. You know, you don't string. You know, you string someone up. Perhaps people want to do that with me now. Hey, but you know, because the class is hard. It's not that hard. Come on. But yeah. Anyway, I wanted a pun, but I couldn't get one. Oh, and by the way, this troll. Give me 1 second. This troll is true. This is a true condition of the internet, except that there is a little good fairy with a magic wand and butterfly wings. And on the side of the wand it reads, unless it's blob data. So, like the exception to everything must be a string is if you have selected the payload format that is specifically binary data, which is used to like send image files and music files and that type of thing. Generally everything is strings, but unless it's a blob. Boy, you really can't see that green marker very well, can you? I don't know why I even bring them. They're so, like, what is even the point of you? So, any questions? Yes?
So for like our assignments and stuff, we will use JSON decode and encode, possibly?
Well, the thing about this class is you are not responsible for any client code in an assignment,
Oh, okay.
right? So
We won't really use decode.
you won't need to use JSON, Stringify, or parse because I will provide you all of the JavaScript you need.
Yeah, I know, but will we
Yeah.
use decode and encode?
Most assuredly, yes. You absolutely need to know how to use JSON encode and decode on the server side. Absolutely. In fact, as I've said often enough, JSON encode is the easiest way to view the contents of a data structure in PHP, because if you just print the data structure, it'll just, like if you print an array, all it will say is, this is an array, and it's like, that's not useful. So, yeah. Does that make sense?
Okay, so encode can put it on the client, and decode is.
Yeah. So if you're sending it out to the client, you encode it. If you're receiving it from the client, you decode it. The other scenario, actually, which we're going to be talking about, in not too long, when we start talking about file I/O, is if rather than kicking it out to the client, you are instead like writing it into a file. Files are also text-based and string-based. So you will have to JSON encode anything you store in a file as well, and then decode it when you read it back out again. Which makes sense, right? Again, and just like our little scenario with our troll and our fairy, the exception to that is, of course, anything that is supposed to be in a native binary format, like image files or music files. Stuff of that nature. Does that make sense? Hopefully? Any questions? Yes?
So this is kind of, I'm not sure if I know for sure, but I've heard like some hackers, they can put like written code in an image and then send it out, and then like, it's just like, if you open it on the image, it runs. Or
I've heard about this before, but yeah, like JPEG, I think there was some way of encoding instructions in it so that if you like opened it the wrong way, it would like run it.
Or if it's just like the image metadata or something, I'm not sure.
Well, maybe. Image metadata is very useful, but I am not aware of how that particular type of attack works. So if I were to say something, I would just be blowing smoke. So there's probably a computer file video on it. So that's good. I'm glad we talked about that. We were going to have that discussion sooner or later. So, I'd like to run through an example now of filtering data that's non-string. So, previously, when we did our string example, we were doing character substitution. We used filter sanitize special characters as our filter. So, where's my red marker? There's my red marker. I'm going to hold up my red marker. This is important. Please write this down. Filter sanitize special chars is for strings. For everything else, use a validate filter of the appropriate data type. Let me show you how it works. So let's say we want to read in n, which is supposed to be what data type? N being the number of elements. What is that supposed to be?
String. Oh, it's
String.
Integer. I mean, it comes as a string, but we want it as an integer because it is a number, right? So, input, filter underscore input. In this case, we are receiving this via post. The name of the parameter is n. By the way, perfectly acceptable to have the name of the variable that results from the filtering operation be the same as the name of the incoming parameter. That's fine.
Is it capital sensitive? If we do
Yes. Yeah, I'm pretty sure it's case sensitive. So, taking a look at our list of validate filters, there are a number of them that you don't have to worry about, and a few of them that are very, very important. Email, MAC address, URL, regular expression, IP address, and domain. These are all for validating strings, right? Validating validating and filtering are two different operations, or validating and sanitizing are two different things, right? So basically, validate email will validate that a string is a correctly formatted email address, right? Validate IP will validate that the whatever you're looking for is a valid IP address, right? What we want are Boolean, float, int, actually bool or Boolean, float, and int. Yes. Right? So let's use validate int since we are reading an integer. Here we go. I sometimes get the question, on the test, are you going to expect me to remember all of these words? And the answer to that is, well, I will expect you to write something that's, you know, in the direction of being correct, right? Like, if you forget the word validate and it's like filter check int or something, you know, I'm not going to quibble over stuff like that. But what I will quibble with is if you are trying to validate something as a Boolean when it is in fact a float or something like that. Like that is substantive, that makes a difference. Everything else is just spelling, right? You should always, this like post is also an important substring that like you need to know if it's post or it's get coming in, right? Question?
The n stands for just the variable or like the, what is the n standing for?
Right there.
Yeah.
So the name that's attached to this input in the HTML is n. Therefore, n is the name we look for in the incoming post parameters. Another way of saying that, if you take a look at the actual contents of the post superglobal, right here, you can see we have n and m as keys. So that these strings are what we're trying to pick out. Does that make sense? By the way, what data type is that? That's right, because it's got the quotes. So, this line in and of itself is the active defense against scripting attacks. It also checks to make sure that the data that we are receiving is correct. So you might imagine, let's say our little website is being used by somebody's great-great-great-great-grand-aunt, right? And this literal 120-year-old woman is reading the web page and says, number of elephants, and then types in 37, like she's writing out a check, right? This is obviously going to cause us problems, right? That won't parse as an integer, even though grandma thinks that it will, right? So, one thing that you could do in this situation to prevent that type of problem is to use some other type of input than text. Use a numeric input. Numeric text box or the slide bar or, you know, one of those things, right? However, and this is also important to know, no amount of client-side validation prevents you from validating on the server. All right? The server must always validate. It must always validate everything, regardless how much validation is happening on the client. Now you may be saying to yourself, oh, but come on. If I use a numeric box here, the only possible output from that thing is a number. How on earth could it be anything else? I can be absolutely assured that the data that's coming from the client is correct and valid. Right?
No.
What should we never do?
Trust the clients.
Never trust the client. Everybody say it. Never trust the client. Good. Just because you've configured your website so that it's difficult, not impossible, to send data that's non-integer here, doesn't mean that some pretty boy hacker hasn't loaded up your web page and is trying to spam your server with bad packets. In truth, everything we're producing with a form here, we can produce with Ajax in the console, right? And with Ajax in the console, we are absolutely not required to only have a number in here because it's a number box, because there's no number box because it's Ajax, right? So the question then becomes, if we have to do all of our validation a second time on the server anyway, what is even the point of doing it on the client in the first place? I put that to you, students, as a question. What is the point of client-side validation, given that on the server we have to revalidate everything anyways? Any ideas? Never trust the client. Well, I mean, at that point we're not trusting the client though, right? Because
That's what I'm saying. You validate it a second time.
Mhm.
So you're not sure that the client's being trustworthy.
yes, yes.
I guess to let them know to write their input a certain way.
To let them know to write their input a certain way. Yes, that is a very good thing, right? If we have client-side validation, that validation will be good and useful for the overwhelming majority of the people using your website. And what it allows is a normal user to send valid packets most of the time, right? One of my favorite client-side validations is the, you know, when you're entering a phone number and it like little pops the brackets and the hyphens in for you? I love that. It's just like, so cute. But that's like that's the type of thing, right? Like it doesn't send the brackets. It's just sending the numbers. It's just viewing. But in order to enter it in, it has to be a valid phone number, right? So yeah. So client-side validation, still important, still good for your end user experience, right? But everything must be double checked by the server. In fact, the server is the only, like, it's more like the server is the first, like, I know, like, temporally this isn't true, but you should think of the server as being the primary check, and then the client as being a secondary check, even though the client checks first. So you're performing the secondary check before the primary check, but the server is the most important check. Does that make sense?
Does the server check on its own, or do you have to do something with the web check?
Well, you write the code in such a way that the server checks it,
Oh, okay.
right? Like when we use filter input, we are writing the server in such a way that it's checking it. Yeah.
So server check is like last line of defense.
No, you should think of it as your only line of defense. Yeah, like the basically. Let me think if I can think of an analogy that uses like medieval strategy games or something. No, I'm thinking more like an RTS game. So like.
Civ 6. Age of Empires.
Imagine you have your castle, which is your database, right? What you want, ideally speaking, because this is software and it doesn't cost anything to write software except time, you want 5 concentric walls and moats in between. That's the most secure, right? Client-side validation is just like, imagine like you have a few spike traps in the field around your castle, right? That's like the role that client-side plays, right? If you have an enemy who can see a spike trap, like even worse, like not even a trap, just like, you know where you sharpen logs and you point them at the enemy, those things. It's just those. It's like anybody who's looking for them can easily see them and go around them. It's the castle walls that are actually protecting your data, and the castle walls are on the server, right? Something like that. So let's talk a little bit about the filter input function itself. There are a number of ways that this can go wrong, right? Let's use the data just a little bit. Say, echo, there are n m elephants in this room. And just for fun, let's filter m as well. Filter input underscore post m. What's the filter we use for strings again, gang?
Filter sanitize special charge.
Yep, sanitize. Good one. Special charges. So, if we say there are 8 frisky elephants, there are 8 frisky elephants in this room. So, everything has been validated, everything is good. Here's a question. What do we get if we don't send any parameters? You can resend, if you reload the web page without using the form, in this case, it doesn't send any post parameters. There are elephants in this room. Interesting. Also, possibly not true. This could be a lie. Filter input produces one of 3 outcomes when performing validation. It produces either false, null, or, in this case, an integer. When it produces null, that means that the packet did not contain the data it was looking for. That's this case. The reason that we get nothing here is because null prints as an empty string in PHP. Right? Another instance, number of elephants, redacted by CIA, average mood of elephants incarcerated.
Whoa.
You'll notice the number has not appeared, right? So, this is because the number that we sent wasn't actually a number. It didn't parse as an integer. It failed on validation. In cases where your data fails validation, the filter input function will return false. False also prints as an empty string. So, let's see if we can work out some if statements to be able to catch these different scenarios, shall we? So, if n is equal to false, that is the case where you failed integer validation. So we say non-integer input. You CAD else if n is equal to null, echo packet did not contain a number of elephants. You founder. And only if you get through both of those do you state the number of elephants in the room. So, let's say we now have $10,000 severely outraged elephants. Sounds like a bad time. We get there are 10,000 severely outraged elephants in the room. Okay, good. Question?
So the other day you told us that the variables are not necessarily variables, but like data types can like 0 for example.
Don't. Shh. I'm just about to do that. So, what if we send this data without having actually sent any data? Well, what did we expect to get if we don't send any parameters? Statement 1, statement 2, or statement 3? How many people think statement 1? How many people think statement 2?
So you're asking what you want to get?
If I request from the URL bar, which means no post parameters were sent, which of these 3 scenarios is correct? 1, 2, or 3? Everybody who thinks 1? Everybody who thinks 2? Everybody who thinks 3? 2 is correct. If the incoming packet does not have the variable that we're looking for, the return result of filter input is null. As you can see, this is the case where we are attempting to handle null, but what are we getting on our actual website when we actually run this? What are we getting?
You get the first one.
We get the first one. Any ideas why this might be happening?
So the first?
As to say, it's the first of the sequence.
It's the first in the sequence. But why should that matter? Because in one case I'm testing for false, in the other case I'm testing for null.
Oh, is it? Oh, because null is also equal to 0 is also false.
That's what you were going to say, right? Yeah. So, false and null are the same under weak equality. This is weak equality. Remember that from last week when I was talking about that? Here's another fun one for you. 0 ghostly pachyderms. 0 is inside of the range of allowable integer values, right? 0 might be correct. It's now being picked up as an error. Why? Because 0 also is the same thing as false and null. So, the solution? Anybody?
Strict equality.
Strict equality. Strict equality using 3 equal signs. Now we get 0 ghostly elephants. Question?
What if we wanna make sure that they actually put a string instead of a number inside of mood of the elephants? Can we do that?
Put a string instead of a number for.
Like mood of the elephants, like it's, we can ensure that they put a string instead of a like number.
See, in either case, it is a string. Like
Yeah.
that would actually. You know how like sometimes like there's a question and like the answer is that's actually kind of hard. That's actually kind of hard because like there's as far as I'm aware, there's no filter that will fail on any string containing numeric characters. What you would probably have to do, what your best course would be to write a loop that loops over the contents of the string, looking for the characters you don't want, and then making a decision based on that. So, okay. When in doubt, pull the for loop out. Any other questions? Yes.
Just to build on that, there's something in Java called, I don't know if this is exactly what it's called, but it was called isInt. So, couldn't you technically do something in the for loop, like if, and O equals false, and I don't even know if PHP has this, but if not int, then you would continue. It was to make sure that, like in Java, it was to make sure that you would actually enter something like a string or a boolean, like, something that wouldn't be an int or that would be an int, depending on what you want.
What's the name of the function in Python? IsInt?
I don't know if it's isInt or isNumber. I honestly forgot.
IsNumeric? IsNumeric works. PHP. Something like that? Okay, so there is. Okay, never mind. You do have a function for it. It's not integrated into the input, filter input. It just takes in a string, returns a boolean. And it seems like, determines if the given variable is a number or a numeric string. So it also works if you just feed like regular floats and integers in. Okay, good. Any further questions? Okie dokie. So, there's something that I wanted to show you folks. Did you know that a packet may contain both post and get parameters at the same time? It's true. Here's a handy little thing which may actually be useful to you. Did you know that in a form you can send query parameters? Like that.
I think you did show it.
Did I?
And like the first, or the second of the class, you did something similar to that.
This is a cool example though. So if you do that, and you specify request as the superglobal, you will get both post and get parameters. You have to actually submit though. There you go. See? Form gets 6. And you can see that the query parameter has also appeared in the URL address bar. Hooray! So, okay. The request superglobal composes the get and post superglobals into one superglobal. You can also get the get parameters through the get superglobal, and that's how you have to get them to filter them anyways. But here's a fun little thing. So, this is a nice little loop that duplicates the form 10 times. But here's the kicker. Anybody see where this is going? What this is going to do is it's going to substitute the value of I in to the string where we are setting what the form number is for the button. So, the end effect of this is if I click this one, I get form number 2, form number 0, 1, 2, 3. See? So not only can we generate all of these forms using PHP, we can also give them identifiers so that the server knows which of these forms was clicked if you send something using one of these forms. So in this example, it's a little bit trite, but imagine the following. Where's my markers? Markers, there. Let's imagine, rather than just a bunch of, whatever the heck this form is, you had, let's say, tweet A, B, C, D, and E, something like that. And off to the side you had like buttons. How does the like button know which tweet it's liking? Right? If you actually click on one, it will attach ID is equal to some number which corresponds to the ID number of the tweet in the database. And these things are generated automatically. Cool, right? Yes?
Is it a while loop or a for loop?
You can use either.
How do you make an infinite for loop?
You make an infinite for loop by modifying the loop variable inside of the for loop in such a way that it never terminates the condition. So, for example, if I were to say, this is kind of an unrelated question, but if I were to say for, I is equal to 0, I is less than 100, I plus plus, and inside of the loop, I put I minus minus. That's an infinite loop. So it's not impossible to write an infinite loop with a for loop. You just have to be a little bit more clever. It's incidentally, it's also possible to write an infinite loop with a for each loop. Anybody want to take a guess at how that works? But what do you do with it? Yes. So if you're appending to the list faster than the loop can knock cases off, then it will never terminate. Question? No? Any questions anywhere? Of any kind? Okay. Cool. So, we're going to switch gears now a little bit, and we are going to talk about the cross-site scripting attack, which is a fairly important, fairly common form of web vulnerability. There we go. Man, this is a horrible chalk brush. I should get a new one.
That's,
So, I would like to run through a little scenario with everyone that demonstrates what a cross-site scripting attack is and can do. But first, can anybody tell me, like, what are your impressions of a cross-site scripting attack? What does it mean? What do you know about it already? Anything at all? Not even a little bit? Yes?
You use scripting tags to hack into somebody's website.
You use scripting tags to hack into somebody's website. So, kind of. In a cross-site scripting attack, the server itself is not what's being attacked. In a cross-site scripting attack, the client is who is being attacked, not the server. So the server itself won't become damaged in a cross-site scripting attack. But yeah, so yes?
Does it use a script to basically use a server to send a bunch of scripts to all the end users or stuff?
So that is a description of a stored XSS attack. There are two main categories of cross-site scripting attack: reflected attacks and stored attacks. A reflected attack is exactly what I showed you in class yesterday. We send something to the server, it reflects it back in such a way that code we don't want to run runs. Right? That thing's still recording? Still got the red light? The little red circle on it? Yeah? Okay. In a stored attack, you manage to sneak your little piece of bad code into a file on the server or into a database so that when the server calls that information up and outputs it onto the screen, you get the same effect, but the origin point of that, of like the place the place that the bad code came from is your own database. So that could be considered an attack on your database, but like the PHP code itself is not under attack. It's just being used as a useful idiot, if that makes sense. The stored attacks are much more serious, as a reflected attack normally targets one user. A stored attack targets everyone who loads that piece of information from the database, which could be like everyone who views a particular forum thread, right?
Yeah.
So if a website has a stored attack, you as the end user can load that stored attack without having done anything wrong, right? The server just sends you the attack because that exploit was embedded into its database by somebody who doesn't like you, right? With a reflected attack, normally you have to do something wrong, all right? So in our case, we're going to talk about a reflected attack, all right? So, the players in our little drama. This is Bob. All right? Bob owns a website. He sells doodads, thingamajigs, and whatchamacallits. Alright? So he runs a website where people pay for things using credit cards. You make an account on his website, you purchase things, etc., etc. Now we have our victim. What's a good old woman name? Betty?
Margaret.
Martha.
Margaret.
Martha? Hmm?
Margaret.
Margaret? Martha? Let's go with Martha. I think Martha is the oldest sounding of all of those. Lots of M names. Last class came up with Mildred.
What about Gertrude?
Gertrude.
Oh,
Ooh.
that is
There we go. All right.
You know it's an old name when everyone's going, ooh.
Yeah. Gertrude.
Or like Greta or something, I don't know.
All right. Gertrude, the unsuspecting victim.
I think Greta. You gotta give her like the Mike Wazowski kind of face, you know?
There's a lot of wrangles.
And she's gonna have that like one bowl on the side of it.
Oh yeah, definitely.
Extra red lips.
Yeah, exactly. Oh, she looks like she gives what grandma kisses.
There you go. And she has like the little thing where like the chain glasses on the chain, right? There we go.
She's always drummy as fuck.
So there we go. Yes, this is still a software class. Thank you very much. And now we have our nasty attacker. What's a good name for a villain?
Sinestro.
Kevin?
That's my last name.
Steve.
I like that because it's French. Yeah.
Steve.
Am I the villain?
Elon.
All bad people are named Steve.
What about Keith?
Bobby.
Bobby?
Oh,
But
Oh, Keith works.
we have Bob
Wait,
over.
his evil twin
Robert.
brother.
Hunter.
Oh.
Hunter.
Hunter. Oh, Hunter is actually pretty
That's
good
too-
because like it's an aggressive profession.
I feel like there's a stereotype of everybody hating the name Hunter for some reason.
Hunter,
Yeah.
the
The wall on the
evil
internet is just everybody.
hacker.
Ooh.
All right, and he shall be. Where top hat,
Someone else has.
with a monocle.
Mr. Monopoly.
No, I'm going more for like Snidely Flash.
Like a Bond villain.
Oh, like Mr. Snowman?
The penguin.
It's like
Give him the nose. Give him the penguin nose, you know?
Give them a rotating bow tie.
Call him fucking ass. He was old.
I do not know what's in the
Oh, you're that way.
There you go. All right, our hacker.
Oh, he's hot.
Eh.
Huh?
Okay.
Wait, what's going on?
Heart of pure evil. All right. Yes.
Is that the name of his malicious code?
Not misunderstood. Understood. Just evil.
No sympathy.
There you go. Not misunderstood. Just yeah. There we go.
He has
Not
no redemption,
misunderstood. Just evil.
no redemption arc for him.
Yep. No redemption arc. He's just evil. So let's imagine our scenario. All right. Let's say that Bob has the website, and Gertrude makes an account on the website, gets her great-great-grandson to order something for her on the website, because, you know, she's an old woman. All right? So she is a user of Bob's website. She has an account. She has, and here we go, stored her credit card information on Bob's website.
Oh no.
Yeah, that's the first mistake, folks. She's done this because it's such an easy and convenient feature to not have to re-enter your credit card information every single time. Right? I'm sure nobody does that with Amazon, right?
Why would anyone?
Now, like, if anybody manages to hack Amazon, I'll be impressed, you know, but yeah, it's the principle, right? And like, fairly big companies have been known to have, like, lost this kind of information, you know?
Like, yeah.
23andMe lost DNA, that's
Yes.
Yeah.
That is crazy.
That's funny.
Wild,
Yeah.
bro.
And they lost their whole board of directors in a day or something, that's
Yeah.
recent.
Here's a little tip for like corporations and like sports teams. If anybody ever receives you have the full support of the board, or they have the full backing of the board, they'll be gone in a week. It's the kiss of death.
Yeah.
Yeah. So anyway, so Gertrude, let's just say that she's doing whatever it is that little old ladies do, like knitting or something, you know, macrame. And Hunter the evil hacker sends her a piece of mail which is infected because it's got green stink lines.
Oh, it's stinky.
Oh,
Yeah,
no.
stinky mail.
Oh,
Yeah.
Why would anyone touch that stinky mail?
Well, because she's lost her sense of smell.
Oh.
Yeah. So,
Oh, man, you know
poor
who-
Gertie. So, in particular, this thing contains a link that is that has an embedded script attack, right? So, poor old Gertie, she clicks on the link, and that's problem number 2. So she does the thing, she clicks the link,
It seems like she has it coming to her.
clicks the link. What a horrible thing to say about a poor defenseless old woman. Oh my goodness.
It seems like she has it coming to her.
Evan, you should come.
What's wrong with you, man?
Bro.
You're a con.
Get out of class.
So,
The con 4K whack, bro.
alright, simmer down.
Yeah, what do you want?
This is actually a lesson, you know. So Gertrude clicks the link,
Yeah.
right? So her web browser, you know, and these things can look very convincing, right? Like, especially now that scammer grammar is not such a thing anymore because of artificial intelligence. Like these things are the spam emails are getting better and better,
They
right?
don't work if you don't check your email.
That's true though. Yep. If you never check your email, you don't get any spam. But so the link contains an embedded scripting attack. What this actually does, it does not contain enough code to be able to destroy Gertrude's account just on its own. What often happens is that Hunter, the evil hacker, will have himself a server, which we will call nastyland.ru. There will be a little piece of JavaScript waiting on this server, waiting to be loaded. What this link will do is it will set the source tag of that JavaScript to this piece of JavaScript here. This one will be loaded into poor old Gertrude's browser. So, to what end? What does the JavaScript do? In this scenario, it steals her session cookie. So Hunter the evil hacker has his hand in the cookie jar.
He's so evil.
Damn, taking cookies without asking?
You still like cookies
That's
at
so-
age 2.
Damn.
Wow, so you can have 1, you took 3.
He's born evil.
Our hacker steals this poor defenseless old woman's cookie, session cookie, right? So what can you do with a session cookie?
Anything that you can do as long as it's open?
Yes.
You can steal, you can impersonate them and see your stored information, like your credit card.
Yes. We're getting there. Yes.
Change their password.
Hopefully not,
Well,
but in this
not
scenario, yes. So what having the cookie allows you to do is he can essentially open up a parallel login session that's running at the same time that poor old Gertrude's is. So now I have to disambiguate here because in the previous class someone thought that this meant that he had like a duplicate of her screen and could read her keystrokes. That's not what we're talking about. They're simply both logged in at the same time, and anything that Gertrude can do, he can do. Right? Yes?
You'd think that they'd make it so like the session key like would only work on the same IP that it's logged in.
Well, I'm so glad you brought that up.
My guess is as to why not is because of
Yes, you're absolutely right.
people
So
being lazy.
you might think that a stolen session cookie, you could get around that by saying, oh, well, Gertrude's got a unique IP address. Hunter the evil hacker has a unique IP address. We could filter, like, the IP address you logged in with has to be the one you log out with type thing, right? But, stupid little magic rectangles getting in our lives game. These things change their IP address when they hop from one cell tower to another. Yes?
Why not use like two-factor authentication then?
Well, in this particular case, Hunter the evil hacker has stolen a valid session cookie, which is the end product of two-factor validation, two-factor authentication. So in fact, Bob could be using two-factor authentication. Gertrude, what's the word? Authenticates. Gertrude authenticates the session, right? Using two-factor authentication. She gets through. He doesn't need her password. he just steals the cookie,
Hmm.
right? And that's another thing about this scenario, is that Hunter the evil hacker does not know her password. He doesn't need to, because he's grabbed her session cookie. All he's grabbing is essentially like the encryption key, the encryption certificate that, oh yes, I'm logged in, which is the thing that the server gives you. It's like when you log in, it's like, here's a cookie, here you go, you are logged in. He steals the you are logged in cookie. Yes?
So, because you said they're logged in parallel, does that mean he's logged into his own account, but once he takes the cookie, it looks like he's logged in as her?
No, he would not be logged in with his own account. He would simply load up the session cookie. Basically, it's very simple actually, because you can create your own cookies. You just create a cookie on your browser, probably php_sesh_id. Give it the value of this cookie, and just load up like the main page of the website. The website will likely redirect you to the home page for that account. Right?
Because I thought it was just like, they both make an account and then like it just changes once you put it in.
He has yoinked her very account. Yes.
I mean, but like, even if he's like in the account on the website, like, what can you even like do with it? Like, usually when you change your password, you need to two-factor authenticate it. Usually when you go into the credit card or any like bank information, you need your password or you need to like authenticate it, and it will send something to your email and
Yes.
all that like nonsense.
That is true, but that's kind of, I was saving that for the part of the presentation where I was like, and this is what they could have done to prevent the disaster.
Ah.
Right. So, as bad as, so right now, we are assuming that Bob,
Making websites.
Bob is not even a programmer, right? Bob has employed his nephew, Rob.
Who is bad at making websites?
Rob, who is a 15-year-old, right? High schooler, who knows a little bit of code, right? Enough code to be able to cobble together a website,
But not enough to make it secure.
but not enough to make it secure. He is our quintessential bedroom programmer, a person who has not been formally educated in security practice and therefore has no idea what he's doing, right?
Fantastic.
Nice kid, but can't program for beans.
Fantastic.
Do we
Okay.
like him still?
All right.
Do we like him still?
I mean, he has the potential to be a better programmer. You know, like he's got potential.
He just needs to study.
It's like all the OpenAI people getting like their Twitter accounts hacked.
Yeah.
So he
Yeah.
just needs to study, is what you're saying.
Yeah, he needs to come to this school and do this program.
I see.
So, but you know, I'm sure many of you in this room can sympathize with like being like the computer person in the family. Anybody? Are you like IT support for the rest of the household? Yeah.
I feel no sympathy for the grandma.
Yeah.
I feel no sympathy for the grandma.
Learn yourself, Grandma. Learn the hard way.
So anyway, so let's imagine that there's no additional barrier to it. Hunter the evil hacker just gets in, changes poor old Gertrude's password, and then logs her out. So because what logging out actually means is taking this session cookie and telling the server that it's no longer valid, it logs out both of them. So if one of these two logs out, both of them log out.
Ah.
But since he's changed password on her,
Just log back in.
he can log back in, she can't. Right?
To be heard then, I guess.
Yeah. And then he takes a look at her transaction history. Takes a look through and notices, ooh, look, there's a credit card number. And there's the security code. And there's the expiry date. The trifecta.
Oh my.
So nice.
And then he books himself a 3-week vacation in the Bahamas. On
Oh, 3
Gertrude's
weeks?
dime. Poor old Gertrude's pension and retirement savings
Buy
gone
retirement
in one transaction. Yes. And that's because, and there are a number of things that we could do in this scenario to prevent this from happening. You have mentioned a couple of these already. Number one, why should you be able to change the account password without providing the existing password? Right? As we said, stealing the session cookie means that you don't need the password, right? You don't need the password to duplicate the session because you stole the session cookie, right? But that's also a vulnerability for Hunter the evil hacker. He doesn't have anything that's behind any further password blocks. He can't get through them because he doesn't have the password. Right? So that's number one. That's a good way to prevent this. Number two, what's another one? Anybody? Someone other than you. Yeah. What's another way we could have prevented this? Yes.
Two-factor authentication.
Say again?
Two-factor authentication.
Well, no, in this particular case, because Hunter the evil hacker has bypassed the login phase by stealing the session cookie, two-factor authentication would not have prevented this scenario.
Educate yourself.
Educate himself? What? You mean Hunter?
Grandma.
No. Hunter the evil hacker is irredeemably evil. There's no amount of improving his childhood that's gonna fix it.
So no morality classes
Better
again?
prevention.
Oh, you're talking about
Yeah,
poor old
Gertrude could have
But
said that
Gertrude
differently.
is so old.
Go
Old
inside.
people are full of wisdom and knowledge. Why is she so stupid?
Well,
Someone agrees
would
with
you
me.
say that about your own
Yeah.
grandmother?
Don't grandma.
You're not stupid.
Get out of that.
So, old people, on the subject of old people are often highly vulnerable to not only this type of scam, but also just door-to-door salesman type
They
scams.
should be embarrassed
You know?
themselves.
Well,
Get out of class.
they grew up, you have to understand, these people, it was a different time.
100%.
You know? Some of these people are 80 years old. You know? Think about it. Some of these people, there are people alive who lived through the Depression. You know? These people. I was about to say, these people are historical artifacts. They should be treated with care. Right?
You're gonna put them in the museum or something?
Yeah, well, but the thing is, relative to a person who's literally 100 years old, all of the developments of the last 5 years in computing have occurred while this person has mainly been playing shuffleboard
Okay,
or something.
counterpoint.
Yeah.
Facebook.
Well, yeah, that's mostly boomers though.
Okay, but they can
Not the
learn.
truly ancient.
Okay, but the truly ancient
Yeah.
aren't even on computers.
Well, except that, poor old Gertrude's
Can she
great
even move
niece
them
or
out?
something got her an email account or something. Very old people often get their younger relatives to help them with their computers.
I'm aware, yeah.
You
This
know.
is a-
So, at any rate, I think that we can construct a scenario where
Change them around.
okay, let's put it this way, all right? If we were to assign blame to the 3 people in this scenario, who deserves the most blame?
Gertrude.
Well,
Obviously the criminal.
Well, okay.
Without the criminal, there is no crime.
Okay.
But between Gertrude and Bob, who's more, who did more bad things? Who did the worst bad things?
Gertrude.
It was Rob.
No.
All Gertrude did was click one stinky link.
Okay, but if I pick up a bomb and then sit there and let it explode in my face, it's gonna who am I gonna blame? Am I gonna blame the weapons developer? Or am I gonna blame myself for picking up the bomb?
Well, at a certain point, if
Bomb doesn't look like a bomb. The bomb looks like a nice
present.
chocolate
Would
cake.
you?
yes,
would you eat
that's
a
true,
random? Would
because
you
it's
eat
a
a random
scam email,
chocolate
it's been
cake?
disguised.
Okay.
Yes.
Would you eat a random chocolate cake that you found
Someone
on the
comes
thing?
up to my door and says, I made you a chocolate cake, I'm your neighbor.
I'm stepping away from you. Obviously, I'm going to poison
a
you.
chocolate cake.
No, this is an old lady, all right? So what it is it's actually it's like a catalog for like crafting supplies, right? Except there's a bad link in it. If you click on it, you die.
It's the
So,
Everyone knows you
The
don't.
person who is most morally liable for this situation
It's Bob. It's
is
actually
Bob,
It's actually
because
Rob,
he
though.
owns the bad website, right?
He should have get his
I'm-
15-year-old nephew to make him a website.
Exactly.
Okay, but Rob is
He
actually.
should have hired one of you guys as co-op student.
Ooh.
So
What are we leaving vulnerability there intentionally?
so the number one thing that could have prevented all of this misery, right, is if the website didn't reflect JavaScript. Right? If the website didn't reflect JavaScript, the link wouldn't be possible in the first place, and Hunter the evil hacker would go find somebody else's website to hack. Right? Because he wouldn't be able to bypass that, like hackers are also like, well, I shouldn't speak about hackers because I don't really know any, but I imagine they're much like software engineers in general, and software engineers tend to be lazy. And if you can find an easy exploit, you'll go with that.
I mean, why not, right?
Right. It's like, I don't know any hackers specifically, but I am aware of humans and human nature, and human beings are by nature lazy. So, yeah. Any further questions about our scenario? Yes.
What did Rob do on his when he was making the website to have it reflect JavaScript back?
You didn't sanitize his special character.
You just use
So Rob's a dumbass then.
We already established that Rob is dumb.
Wait, no, you said he had potential. That is not potential. That is Rob being stupid.
Hey, even if you're using ChatGPT, you still have to figure out how to hook it up.
Okay, but Rob
Right.
just.
It doesn't take zero skill to use, you gotta at least know something about programming to use ChatGPT.
Okay,
to program.
from 0 to 5 is not a big jump though.
Yeah. But anyway.
There's a good saying that I heard from a software engineer. It said, you're not going to get replaced by AI, you're going to get replaced by someone who knows how to use it.
Yes. Yeah.
Because if you actually know how to ask ChatGPT what you want, it can be pretty good.
So,
If you know how to use it.
That's called.
I must admit, I have been dabbling with this.
Why sometimes?
I find that, like,
You curse a
the type of query that, like, 5 years ago I would have entered into Google, expecting to see a Stack Overflow article that, like, gives me, I have to read 3 paragraphs and there's my answer,
Yeah.
It's pretty good at just giving you the answer.
100%.
On those types of questions, I wouldn't have it generate a whole program
Oh,
for me.
100%.
Yeah.
Just saying is you're a traitor.
Who's a traitor?
You
I am?
using chat
The accursed
What?
the
chatbot?
cursed
I know.
the accursed
I-
bot?
Yeah, it is. No, I understand. I understand that I'm sullying my soul by doing so.
It's like being a Microsoft there.
But, like, here's the thing, right?
Saves him like
Unless you engage, like, to defeat your enemy, you must know your enemy,
But then you become your enemy.
Well, see, that's the thing, is you have to pull back before you hit the point of the void staring back into you. Right?
Did the void smell bad?
Yeah.
Sir, what's next? Are you gonna start shilling Microsoft for
I was gonna
us?
say, he's gonna give us all Microsoft OS stuff.
You
Yeah,
know.
replace all your
Windows
Windows.
11
Start
all that
shilling
stuff.
Windows 12. Windows 12.
Well, how are they gonna make it worse? Hide it in dates.
Probably what should happen is you should just
Open
set the
up the
server
fucking
on
lock
fire.
screen and there's a giant subway ad.
Start over again.
Like the first
Alright,
thing you do.
30-second ad.
Thank you very much, everybody. Don't cheat on assignment 1, please.
Like the very first thing you do when you install Windows 11 is immediately go into the registry and make everything work like Windows 10 did, because Windows 11 works on